I'll review the code in these scripts now while discussing object-oriented programming concepts that were used. Most of the code for the challenge was added to the GameSettings.cs script that we had originally attached to the GameSettings panel. As mentioned previously, I renamed the script to GameController.cs and attached it instead to the GameController object. Let's look at this script in detail. The using statements at the top simply provide our script with access to other classes defined in other scripts. What exactly is a class? Well, we are defining our own class here named GameController. A class is not an object. Instead, it is a blueprint for an object. Anytime you see the new keyword in C#, you know a new object is being created from the blueprint. In CS terms, this is called instantiating an object, which simply means you are making a new instance of the object from the class. So when a new object of type GameController is created from the GameController class, it comes with a lot of attributes and behaviors. Objects have attributes, and we use properties to store these attributes. Objects have behaviors, and we use methods to define these behaviors. Imagine having a dog object. It would likely have attributes such as color, speed, and breed. And it would likely have behaviors such as run, bark, and sleep. This is true of any object instantiated from the GameController class as well. We never wrote code with the new keyword to create an instance of a GameController. In Unity, objects can be instantiated in the editor. When we attach the GameController.cs script to an object in the hierarchy, objects are automatically instantiated for all the classes defined in the script. The colon behind the class name indicates that our class is extending another class, and so will inherit methods and properties from another class. So our GameController class is extending the MonoBehavior class and inheriting all the methods and properties of MonoBehavior. This means that our GameController object is also a MonoBehavior. Consider our dog example. If there was an animal class, our dog would inherit from animal. So when we talk about inheritance in computer science, it is only somewhat like when we talk about inheritance in life. Yes, in our example, a dog does inherit attributes and behaviors, but it does not inherit them from another dog. So the methods and properties common to all animals would be defined in the animal class, and each specific type of animal would then inherit all of these methods and properties. The only methods and properties that would have to be defined for a dog are those that are unique to dogs. This avoids the need to rewrite code, and it allows an object of type dog to be treated as an animal. Let's look at the API for MonoBehavior to see what properties and methods that our GameController is inheriting. If we scroll down, we see MonoBehavior has two properties. Under these properties, we see the public methods that are defined. Because our GameController is a MonoBehavior, we could use any of these methods in our class. Notice there is one static method. Static methods are not applied to instances of an object. If you create an object of type MonoBehavior or of type GameController, that object does not have a print method. To use the static print method, you do not need an object. You would simply use the class name followed by a dot, and then you could call the print method. The messages listed here are also methods. However, these are methods that do not need to be called because they are already being called by the Unity engine. We have used some of these. If you scroll down, you see onCollisionEnter and onCollisionExit. Further down, you see onTriggerEnter and onTriggerExit. And at the bottom of the list, you see Start and Update. Under this, we have more properties and methods that are inherited. This means that the MonoBehavior class must have extended another class and inherited all the methods and properties from that class. Let's scroll back to the top, and yes, we see the MonoBehavior inherits from behavior. If we click on behavior, we see it has its own properties and methods, and it inherits from component. And component inherits from object. And finally, we see that object is the base class for all objects Unity can reference. Everything in Unity extends from object, so everything in Unity is an object. Our seemingly simple GameController object is also an object. It is also a component. It is also a behavior. And it is also a MonoBehavior. As such, it has all the properties and methods defined in those classes, as well as the methods and properties we define in the Game Controller class. Wow, so much in a single line of code. This may seem very abstract right now, and it is. It takes time to develop a strong understanding of object-oriented programming. Another object-oriented concept is encapsulation. Each of our properties defined in the class are set to be public or private. We have already made a distinction between the two in regards to what properties appear in the editor, but there is more to these accessors than that. Public properties, as well as public methods, can be accessed by any other classes. Private properties, as well as private methods, can only be accessed by the class in which they are defined. So our pause key property can be accessed and modified by other classes, but only the Game Controller class can access and modify the private properties. You should try to use private properties whenever possible to ensure that control over your properties is maintained within the class. Data encapsulation is an important object-oriented concept. Allowing other classes to modify data of an object directly can lead to errors that are difficult to track down because they could be caused by code in any class. Each property defined has a type. You already know the primitive types of int, boolean, string, and float. Properties with a primitive type simply store a single value. Properties defined with a non-primitive type can store any object instantiated by a class of that type. And we know objects are much more than a single value, but can hold many values and have many defined behaviors. Properties that have a non-primitive type are simply references to the objects they store. For instance, the GameCanvas property is defined as type GameObject. Yes, I could have defined this as type Canvas, but I do not need to use any properties or attributes that are specific to Canvas objects. Compare this to character name input, which is defined as type input field. In the script, I use the text property that is defined specifically in the input field class. This is why I am more specific in defining the type for this property.